Hello, everybody, and thank you so much for joining us for a lighting legislation webinar featuring experts from the Green Restaurant Association and Philips Lighting. My name is Charlotte. I'll be moderating this webinar today. And as we get started, I just want to take you quickly through our agenda for this morning. Going through an introduction now, and shortly, Michael Oshman, the CEO and founder of the Green Restaurant Association, will put in a few words. 5 minutes into that, Brian Vetter will take over. He's the portfolio manager for Philips Lighting, and we'll be discussing legislation and the ban on incandescent bulbs and energy-efficient solutions for your restaurant. 35 minutes later, we will enter into a Q&A session, so please ask any questions before entering into the drawing of our LED bulbs prize. Our webinar will be closing around 12 o'clock. So here today, I am going to introduce Michael Oshman to say a few words. Here, Michael.
Thank you, Charlotte. Thank you, Brian, and thank you for everybody attending today. This is an exciting webinar that affects really not only every restaurant, but truly anybody that is using light bulbs in the United States. And I know that many people in our country have questions of what's banned, when is it banned, and the intention of the next hour is to answer a lot of your questions. So we'll start with a little bit of background for a few minutes before passing it on to Philips. Some background on the GRA is that we were founded in 1990. We're a national nonprofit organization. We have one mission only, and that's to shift the restaurant industry toward ecological sustainability. We've done that quite well over the past 22 years, and there's a lot of work to still be done. We've got the largest database of green solutions for the restaurant industry. Helped thousands of restaurants over the past 2 decades. We have 500 restaurants that have actually achieved the minimum of certified green restaurant standards, and that is in 42 states and Canada. Those are transparent science-based standards that you can see online at dyinggreen.com. We have the most experience of any organization on the planet helping restaurants to go green. We're endorsed by scores of environmental organizations, governmental organizations, such as Natural Resource Defense Council, New York State Restaurant Association, and State of New York. For our restaurants who depend upon their consumers to come in, they want to attract attention for all the wonderful things they're doing, and we provide a transparent way for the restaurants to communicate what they're doing, and that's why thousands of media have come to write and feature these restaurants in stories. CNN, Martha Stewart, NBC Nightly News, New York Times. It's also why some of the most prominent restaurants, such as Mario Batali's Del Posto and all of his restaurants, Frontiera Grill, Topola Bamba, and Rick Bayless's other restaurants, Culinary Institute of America, Sweet Tomatoes, Boston University, Microsoft. These are places that want to go green, want to do it in a transparent way, and want to make sure that they're doing it in the right way. Why go green? One, as you'll hear later in the presentation from Brian, there's a great opportunity to save money. LED bulbs alone can have a payback in just a couple years, and they can save thousands of dollars. Shifting over to recycling and composting could save thousands of dollars. Shifting over spray valves, reducing waste, reducing water. These are all opportunities to save that every restaurant really should be doing today. The paybacks have just gotten so great, there's really no reason not to. Restaurants also do this to get noticed, to get customers in the door, to improve staff morale. The 78% of employees prefer working at a certified green restaurant, and 79% of consumers prefer dining at a certified green restaurant, according to May 2010 Technomic survey. There's a lot of very powerful reasons. In addition, staying ahead of legislation. You'll be hearing about the lighting legislation today, but there's other legislation, from styrofoam bans to recycling mandates, composting mandates, bans on plastic bags, etc. We just published an article called The Green Side of the Law that talks about legislation regarding restaurants and the environment. Anybody that wants that, please email media@dyinggreen.com, and we'll be happy to send that article to you. And last but not least, an opportunity to improve the environment. Restaurants not only get all these great business benefits of saving money and attracting new customers and retaining employees and good media. But at the end of the day, they're truly at the forefront of saving our precious resources that will ensure the next generation is not left with an environmental debt. How do we do it? An environmental assessment to score all the great things the restaurant's doing right now, find the room for improvement to help the restaurant get to the point of 100 points to be certified. We strategize on which steps and actually provide the restaurant with actual product numbers and suggestions and various options to actually make the change. We're not leaving the restaurants in the dark to figure it out on their own. We then go through a verification process that not only the federal trade government organization wants that sense of transparency, but consumers deserve that sense of transparency, and so we provide verification, green labels. Consumers can see everything that these restaurants are doing. Certification, public relations, marketing, exclusive listings on AAA, city search, and education. GRA-endorsed products meet the top tier of our environmental standards and offer the greatest environmental benefits in their category, and you can see them all at the link at the bottom of this page here on dyinggreen.com. GRA just recently endorsed 39 LED products from Philips Lighting. Specifically, one of the most exciting ones is the L Prize that just won the $10 million Department of Energy prize that they put out to create a bulb that can achieve a particular level of efficiency while also shining a light that a restaurant or a home would want and be proud of and would look good. Restaurants can also earn 18 green points for using all LED lighting in their restaurant. Restaurants such as Eric Repairs La Bernardin have already done it. 67% of their lighting is LED, and they're earning over 12 green points just for the LED lighting. Asheville's Green Sage has done over 90% of their lighting, earning over 16 points. It's doable. Restaurants are doing it now. They're saving money, and it looks good. Benefits of LEDs, you could save up to 83% of your total lighting energy. Stay ahead of legislation, as we'll hear more about in just a few seconds, and you'll be able to receive rebates, knocking down the payback time to a couple years. So we're very, very proud to have endorsed the 39 bulbs from Philips. We're very proud to be presenting to you this webinar on legislation, and I will pass it on to Brian of Philips Lighting.
So, hello everyone, this is Brian Vetter with Philips Lighting. Thank you for joining us today, and thanks to the Green Restaurant Association for allowing us to come in here and talk a little bit about the legislation update. So there has been a lot of changes in the lighting industry targeted at reducing the overall energy usage and our energy dependence, and that's we're going to give you an update today on. So the agenda will cover the general service incandescent legislation, so going over the general A-shaped lamps, go over reflector legislation, which has a similar goal, but certainly covers different products. For those reflector type products, we'll go over certain compliant options, and then give you at least a little bit of information on what to do to compare the options. We'll go also over some of the TL, so the linear fluorescent legislation. I know that doesn't have as big of an impact to this group, but I think it's important that you are aware of what's going on, and we will tell you that. The rare earth oxides is the reason behind the fluctuation in those linear fluorescent pricing. So I just wanted to quickly go over that. Finally, sum up with some rebates and a little bit of how to get to them, as well as what exists today. And then finally wrap it up and have Q&A at the end. So with that, we'll go through the general service incandescent. Well, first of all, we'll start off with a polling question. And have you considered a complete lighting retrofit within the last 18 months? So I'll give you a chance now to, I guess you can, a yes or no in the meeting chat, or raise your flag by using that function of the interface as well. Okay, we'll give it just another 5 seconds or so. And we see a few folks have thought about, at least through the based on the flags, have considered doing a lighting retrofit. And as Michael was saying, it is an important part and can have a huge impact not only on the bottom line of the business, but the overall atmosphere of the restaurant, which is critically important. So with that in mind, here's a quick summary of the legislation. So there's really 2 parts of that, and it's all brought up in the bigger Energy Independence and Security Act of 2007. It was signed into law by President Bush in December of that year. It had 2 sections, the 321, which is the A-shaped lamps, essentially, and also some globes and those types of lamps, as well as Section 322, which features the incandescent reflector legislation, but also covers the general service fluorescent lamps. At the bottom, we see the timeline. We're now towards the end of 2012, but in July of this year is where the reflector and TL ban hit, and that was had a very large impact on a big portion of the industry. So not only restaurants, but retail market as well. And you can see that the general service fluorescent, there were some lamps that were exempted, especially just because of the REO prices, and they were originally banned in July and will be banned now 2 years later into 2014. But what we still have coming up is at the end of this year, the A-shaped 25-watt lamp or 75-watt lamps gets banned, and then finally at January 1st, 2014, the 60 and the 40-watt lamps are banned. On this slide, we see the difference between, or the background of the A-shaped lamp ban. So you can see it's general service application. It has to have a medium screw base. If it has a candelabra or intermediate base, there are different standards for that. The legislation was written around the lumens. So while we generally speak of it as a 100-watt ban, the truth of the matter is that it affects lamps based on their existing lumen range, not based on the wattage. But the lumen range generally covered lamps somewhere between 40 and 100 watts, and even some of the lower performing 150-watt lamps were affected by the legislation. And then the final piece of this is that it has to be operated in the range of 110 to 130 volts somewhere. The chart at the bottom is really the meat of the legislation. So you can see that the current wattage is 100, and that gives you a lumen range of somewhere between 1490 lumens to 2600. So based on this legislation, the way it is written, I could actually have a 1000 lumen 100-watt lamp, and I could sell that today. Likewise, I could have a 300 lumen 100-watt lamp and continue to sell that forever. So that's a little bit of the caveat. I just want to make it clear to you that there is a difference there. It's not based on wattage, but based on lumens, and that's how it's written. Now, if you're switching to LED, you don't have to worry about this. The only technology that still plays with this lumen range and wattage really is halogen. So standard incandescent will be gone, and it will now move to the halogen as your entry point, and then obviously CFLI, which has been around for a while. And now, as Michael alluded to, many of the LEDs, especially the Philips LED, is really starting to show up very nice. As with most things that the government does, they have many exemptions for all kinds of different reasons. The exemptions based on application, so you can see like an appliance lamp, a marine lamp. At the moment, rough service and shatter-resistant lamps are also exempted from the legislation. However, their sales will be monitored by the DOE over the next several years, and if their sales increase by a certain amount, they will too be affected by the legislation. However, after a year of having the 100-watt, essentially the 100-watt lamps banned, we have not seen any indication that these rough service or three-way lamps will become affected by the legislation. They also made some exemptions based on the bulb shape. So for example, if you use a G40 or greater, there is no maximum wattage, and it will remain a viable lamp for the foreseeable future. Then for other types of lamps, such as candles, the B, BA, CA, as well as F-shape and many globes, those can be 40 watts or less. So it doesn't matter if you have a medium base 40 watt G30 lamp, that one survives the legislation. So with that said, what do we have as solutions? As I alluded to, we have halogen and infrared halogen. I'll get into the infrared halogen for those who are not familiar a little bit later. But obviously they will offer the lowest initial cost. So today they're roughly around $1 a bulb. And it's exactly what you're looking for, or exactly what you would use if you have an incandescent today. So it dims perfectly. It's instant on. The color is very much the same. But then it does have a very short lifetime. And the energy saving versus an incandescent is only around 28 to 30%. CFLI, on the other hand, I think most people on the call are quite familiar with it. I guess the biggest concerns are generally shape and then the dimming, as well as the lighting characteristics have not always been up to par. And then finally LED. The initial cost is always higher, but with the utility rebates, and you'll see I have an example at the end that shows that even that if you include a utility rebate, the payback by using an LED bulb can be less than 1 year. So, and I also think, as Michael said correctly, the light quality of the LEDs is improving significantly, and every 6 months you're starting to see better and better light qualities out of these bulbs. Now we'll talk about the reflector legislation. So in addition to the A-shape, the government took a chance to regulate the reflectors. So generally going after like PAR lamps as well as the R and BR type lamps. If it would be affected if it falls in the range of 40 to 205 watts, as well as 110 to 130 volts. What it means is that manufacturers and companies may not manufacture the lamp or import it for sale after the effective date. So today, even though that the legislation went into effect, as long as we had inventory in the U.S., you could still probably find many of these lamps around. We expect that to last for maybe 6 to 8 months based on what we saw with A-shape, but I would not expect those to be around for too much longer. Notable exceptions are the MR16s, because they're low volt. They are not affected at all by any legislation at the moment. And PAR 16 lamps. They excluded the PAR 16 lamps because there's just not enough of them used in the country, and therefore they did not see it as a significant way to garner energy savings, which was the goal again of the entire legislation. Now you may have heard word about the government, the Department of Energy, not being able to spend money to enforce the standards. And that is true. Prior to the election, I think it was in October, they signed a bill to extend that to the end of March 2013. So at the end of March 2013, the DOE can again begin to enforce the standards. In the meantime, you still have individual citizens as well as non-governmental organizations that can go out and sue manufacturers for bringing in bad product. From the user side, you don't have anything to worry as long as you're not buying direct from China. If you're buying from somebody within the U.S. who has delivery from a U.S. location, the onus is all on the manufacturer or supplier at that point. And as long as they have the product and you can buy it, then you don't have to worry about being sued or falling ill of the law. So that's, I just want to make sure that that distinction is clear to everyone. Some details about the reflector legislation. So you can see that they made up a nice little chart here. Nima put this chart together to try to describe it. It starts off with a wattage of 40 to 205 watts. Then it breaks down to a lamp type. So standard spectrum is the primary, covers 99% of the lamps that are out there. You will see the other possible type of lamp is a modified spectrum, and people may know that as the GE Reveal brand. So the kind of the blue tint, a little cooler running or cooler appearance lamp. They have some lower standards. because those lamps are unable to meet the same as a standard spectrum. But that's not where the majority of our lamps will fall. Sorry, a little technical difficulties, folks. I'm going to try to kill that music. There we go. Thank you. All right, and then the voltage. Many of you may use a product that is a 130 volt lamp, and the government set higher standards for 130 volt products, so those will be going away. I doubt that you will see many products from manufacturers that will be marketed as a 130 volt product anymore. So that's another distinction that you should see. And then finally, there's an equation at the end that defines the efficacy, or the lumens per watt of the lamp. So in this case, it's you use that 5.9 times the power in watts, raised to that 0.27 power, and that gives you the efficacy required. So with all the technical mumbo-jumbo aside, lamps ranging from 40 to 205 watts will have to have somewhere between 16 to 28 lumens per watt in order to meet the legislation. So here's a quick look at how to check to see if a lamp is compliant. So taking a 60 watt par 30S as an example, with 800 lumens, it has 13.3 lumens per watt. The required lumens per watt based on the equation is nearly 18. Therefore, it does not meet the standards. So then let's take a look at it in two different ways. All right, I have a 60 watt lamp. I'm happy with 60 watts for some reason. I would need to have almost 1,100 lumens in order to meet the legislation. Similar-wise, if I had what wattage would I need to maintain the same lumens? So for an 800 lumen lamp, I would need to have somewhere around 48 watts at a maximum in order to maintain the same light output. So in the end of the day, it comes over here and you see that after legislation, a 60 watt lamp will give you 34% more light, or for the same light output, you will use 20% less energy, and that's at a minimum per the legislation. This is just a page to, I guess, do a little bit of the homework. So if you can see where the lumens are, required lumens per the legislation. Here, we've given you the maximum wattage that it can be, and then the efficacy. So that's just a quick summary chart for your reference. Now moving on to the legislation compliant options. First up is the legislation compliant halogen. So there are several ways that they can tweak the halogen technology in order to meet the legislation. The first thing that they can do is they can coat the burners with a filter that allows IR energy to be recycled while passing through it visible light. And that way they're able to do this, achieve the light output of the lamp more efficiently. They can also take the reflector itself and try to improve its reflectivity based on the burner itself. So they can put like a silver coating or some other unique material coatings in order to increase that. Because when you take a halogen burner inside the reflector, if you have 100 lumens out of the burner, the reflector in the total lamp actually only puts out about 80% of those total lumens. So you can see by increasing the reflector performance, you can really gain quite a bit in the lamp. Another option is to reduce life hours, and then finally changing the gas mixture. These are all used in order to meet the legislation. Halogen in general have a lifetime of somewhere between 1,000 to 5,000 hours, and it just depends on your particular application, which one's available. There's an integrated HID lamp, so ceramic metal halide. Similar construction to a halogen lamp, where you have the optics to shape the beam, the reflector, which helps turn that arc tube or the burner piece lumens into usable light. An integrated electronic ballast, and that's used to control the electricity as well as start it up. And then finally a housing just to hold everything together in a familiar shape so it fits within the fixtures. LED technology. This one is again, many of the same components are there. We need optics in order to control and shape the beam. The LEDs themselves are a very small part of the total package. And you can see them, they're just those little yellow dots on the board. So the overall size of the chip is quite small, but that's what's creating all of the light. Something very important to LEDs is thermal management. So a good LED lamp will have extremely good ability to get the heat away from the LEDs themselves. And that's important because as the LED heats up, it becomes less efficient. And also it ends up dying much faster. So in order to achieve the long lifetimes, we have to be very good at getting the heat out of the LED itself. There's an integrated driver, as with the HID integrated, and that's built in there, and that's what controls the light output, the lifetime of the lamp, as well as dimming capabilities and dimming compatibility, which those are two important aspects if that's what you're going to use in your application. And while I have shown here a reflector, a BR30, for example, the A-shaped type lamps, so the L Prize winning lamp follows a very similar type of construction with the same types of pieces to it. So this slide, I wanted to just give you a brief rundown of how the LEDs actually make the light. So it's significantly different than other forms of lighting in the past, especially when you consider halogen, or incandescent, where you heat up a filament until it gets hot enough and produces light. LEDs are actually a semiconductor diode, and there aren't any moving parts, so therefore they are much less sensitive to vibrations or any kind of movement, which makes them very good for certain applications. That's not to say that they are completely unaffected by vibrations. Obviously, from the previous slide, you saw how many parts had to be put together. Those little pieces can all come apart if it's shaken too much, but that should not be, for the most part, that's not a concern. So the diodes have two different types of material, a P-type material and an N-type, and then there's a junction in between. And as you apply an electrical current, the electrons that are in the N-type, the active region as you see there, they want to jump over the junction and into the P-type so that everybody's at an equal, everybody gets to equality. When it moves, when the electrons actually move from the N-type to the P-type, it releases a type of electromagnetic radiation, or in this case, a photon in visible light. So that's the basics of how the LED itself works, and I think it's what's really neat about it is that it is a completely different way of generating light than just heating up some kind of a black body and having it incandescent. Which brings us now into the second polling question. So let's do the first half of this. How many of you use dimming? Use the dimming feature on a daily basis to create the correct ambiance in your application, in your restaurant? Okay, again, it's looking like a few are doing it, a few more coming in. I'll give you another 5 seconds to raise a flag if you do. Okay, so that seems to be a fairly important feature to have. And then finally, have you evaluated LEDs for your site? So if you want to either keep your flag raised or raise it again, I'd appreciate your feedback. Okay, so seems to be much more interest in LEDs. So this is something certainly that we're hoping to bring a lot of good products and good information to you about that. Okay, thank you very much for your feedback. Appreciate that. So in order to find the GRA endorsed lamps, as Michael showed up before in his little presentation, they do have a website, and these can help you gain points towards your certification. I have the web address right there, and there's a quick little snapshot. It looks a little fuzzy, but it lists the part number and exactly how to get a hold of that lamp. Now moving on to comparing your option. Okay, now that we know all of these different technologies exist, what can we do to compare them? This chart is just a very basic one. So it lists 5 key design considerations: energy efficiency, the initial lamp price itself, the lifetime of the lamp, whether or not it's mercury-free, which certainly goes towards the green concept, and then finally light quality. So if we take an example of the halogen, obviously we know that the energy efficiency is the worst out of the group, but then it's going to be the cheapest lamp. While if you take a look at the LED, it has the best energy efficiency, best life, mercury-free, and the light quality, some people may argue that it even matches halogen at this point, but certainly better than most of the CFLs that are out there. And this is just meant as a little tool to maybe help guide your thinking and guide some questions as you pursue LED lighting. Here's another way to look at the lighting technology. So if we look at, for instance, the LED, why you would choose LED over CDM, for example. It does better on energy and has longer lifetime. Versus halogen, it has a much better total cost of ownership story. And when you compare LED versus CFLI, it has longer life and better light qualities. So again, another just quick little chart to try to help you think about the lighting, your lighting options, and what you can do, and what options you have, and why you would choose one over the other. Another thing to consider is, if you're considering the LED right now, you're being forced to change by the legislation, the lamp you currently use. Switching to a halogen or a shorter life HID type lamp may be a very good bridge while you consider your options, and that's another piece to consider. So final polling question of the day, do you have or have responsibility for multiple sites? So if you could either lower your flag or raise it, I'd like to see that feedback, please. Okay, it looks like several people do have multiple sites about which they're responsible for. Thank you very much for the feedback. This slide now, I want to spend a little time to discuss, because this looks at operating costs for a single socket. And I'm considering operating costs to be just the lamp cost and the energy cost. Any labor, I'm assuming, if you had to install something somewhere else or to change the light bulbs, I'm assuming that's done by restaurant personnel anyway. So it's just considering lamp cost and energy cost. And what you'll see here is that the dark blue line that soars above all of the others is the halogen, and that's not what you want. Obviously, that means an increasing cost. So each year you're buying a lamp as well as paying the full amount in energy. And in the first year, the halogen is a better cost solution, operating cost solution, than the LED or HID. However, the CFLI, due to its lower energy costs, despite the fact that it's generally a little bit more expensive per bulb, is a better operating cost solution than the halogen. But what's striking to me here is how quickly LED becomes the better solution versus the standard that we have today. So even versus the HID solution, it pays itself back within the first 2 years. Now this particular example does not consider any rebate costs. So you can imagine if you add $15 to a $15 rebate to an LED, how much better the situation would look. So after 5 years, when you've replaced your halogen and had to spend $150 for a single halogen lamp, you're somewhere in the range of $60 to $75 for an LED, and that's at the same point of the CFLI. So if you know the type of lamp, you do your research and you test out the lamps that you want, and you want to switch to LED, right now within 5 years without any additional rebates, you should see the complete payback even versus an existing CFLI lamp. So I think that's a pretty striking example. So CFLIs are still very cost effective in the right application, but LEDs, despite their high initial costs, which are being offset in many places right now by rebates, they quickly become more cost effective due to the super low energy consumption. So a couple ideas of what you want to look for when switching is really the replacement should be based on performance. No longer do you say I want to replace a 60 watt with a 60 watt. It should really be based on the lumens as well as the light appearance. In order to help that out, in all of the catalogs that are out there, there should be this lighting facts. So you see the information. This is an actual lighting facts label that's required on the packaging and consumer, and it shows you the brightness or the lumens, an estimated energy cost based on 3 hours a day and 11 cents per kilowatt hour, the expected life based on those same 3 hours a day, and then finally the light appearance. You can see that the last thing that they feature on this is the wattage, which that used to be the primary gauge. When you look at the performance specs, you really want to focus on the lumens and the candle power, the delivered light. Is it creating the ambiance and the look and the feel that you want? And then finally, the lifetime of the wattage will have an impact on the cost. But you really want to focus on the light. Do an installation if you can. Do a test store, a corner of your restaurant in order just to make sure that it gets the right feeling. And once you find that, then you can focus more on the lifetime of the wattage and the other pieces. But it's really important to give that right experience to the customer. Cost is another consideration. When you're looking at electricity usage, is it a separate cost or is it included with your building budget? There may be some that are in malls, for instance, that perhaps don't have a separate electricity bill. And there it may change your idea about the payback, because then footing the bill for an LED upfront cost may not pay you back. But that's all for each individual case to look at. The image on the right shows the states, the electricity rates. So you can see if you have a store up in the Northeast or in California, the electricity rates are quite high, anywhere from 13 cents to 26 plus cents per kilowatt hour. And in those situations, the payback on the LEDs quickly adds up. And the final piece I'd say is, what is your return on investment horizon for upgrading? So most of us operate on an annual budget, but if you can work it so that you have your lighting budget might cover 2 years, maybe a little bit longer, switching to LEDs is a very cost-effective and quick way to make the transition. A little more detail. I won't go through this slide in complete detail, but again, I just wanted to look at some different key components, key specifications of lamps, and how you can go about trying to compare them. For instance, lifetime. This is one I think that's a big difference between the standard conventional technologies versus LED. So the lifetime of a conventional lamp is a time at which 50% of the lamps will fail. So if you have 100 lamps, the time that the 50th lamp fails as you have these running, that's the B50 point. On the LED side, it's usually marked as the B50 L70, which means the point at which 50% of the lamps will lose 30% of their light or maintain 70%, the L70, the 70% of their initial light level. So and it's all based on calculations. It's not based on actual testing, where the conventional technologies actually have to burn their lamps for their rated lifetime. The other one I would talk about is lighting controls. There are some issues with compatibility and dimmers, but for the most part, the LEDs are doing a much better job at working with all kinds of controllers and dimmers. Here's a quick map. I will get into a little more of this detail later. The LED utilities that we have available, anything that's green, there are active utility programs. The orange states are programs that are in the works, and then the couple in gray, there isn't anything active at this time. So as a quick summary for this, you can see the reflector types, 40 to 205 watts, and as far as options, we have the HID, LED, and CFLI. The TL section. This is the real detail. Again, I won't try to bore you with too much of that. The effective lamp types. Essentially, if you use any T12 lamps, those are going to be the ones that you're going to want to transition to a T8 or T5 solution. There was an exemption given for certain T8 lamps for 2 years, and that will last until July 14th of 2014. If you're using here's some replacement solutions. So if you use a T12, then you can either use a conversion kit to a T8 or use some T-LED. And if you're using the current T8, you do have that T-LED option, a higher lumen per watt T8, or you can use any of the exempt lamps. Here, I think if you're using a T8 today, probably you can stick with the 700 series T8s until 2014, and then at that point, we'll have to make another decision. Quickly on the rare earth oxide. So REOs are phosphors that are used in fluorescent lighting. They're used in TLs as well as the PL lamps and CFLI, or the little stick lamps. And you can see out of these rare earths, which you see here on the left-hand side, there are 5 that are really specific to lighting. This chart shows which ones are in critical supply based on the U.S. government. So the government has indicated that all 5 of the lighting phosphors are in critical supply. And then that's the whole reason that we're seeing these crazy fluctuations. So as we are dependent upon China, because that's where 99% of these phosphors are coming from right now, as they change their export quotas, that's going to influence the pricing. So that's the main message there is I will say that I would expect continued price fluctuations out of the TL lamps, and I don't see that settling down for the next 5 years. Now into some of the rebates. So there's a couple different types. So the consumer, that's already done at the shelf. So when you pick that lamp up and you buy it, the markdown has already occurred on shelf, and there isn't anything else to do in order to achieve that rebate. On the commercial side, they offer some cash incentives, and then that's where you have to, there's more to do in order to achieve that. So there's several different commercial categories. Obviously the existing building, new construction, as well as small business. And for each of those then, within the commercial category, there's prescriptive, which gives you a set incentive, a cent dollar amount based on a specific upgrade, or custom, which pays you based on kilowatt hour or kilowatt reduction. So you can see here some examples of rebates that are offered. Different types of rebates per fixture. So if we look here at the A19 fixtures, the Philips and DuraLED offer somewhere between $10 to $20 per lamp savings, and you can also see a $10 to $25 per lamp in the recessed or cans. And then there's also in the dimming and controls area quite a bit to be saved. So I guess the overall message here is don't be scared off by any high initial price of an LED. Remembering the chart that I had before that showed almost the entire country with active utility rebates, there are ways to get rebates on LED and CFLI. They're all over the place. So you want to talk with Philips, we can certainly help you with that and find your answer. So again, that's why I just went over why do we care about this? Reduce that initial shock of the high price, shorten the payback period, as well as increase your return on investment. Here's the example I wanted to talk about. I got messed up a little bit. In any case, if we take a look at a 35-watt halogen MR16 versus a 7-watt LED, the energy cost is $14 on the halogen versus $2.80 on the LED. The operating cost, so the cost per lamp then is $5 versus $15. So you can see the savings for the halogen, but then the total operating cost within the first year is less for the LED versus the halogen based on the energy cost and the total cost per lamp. So I think this is a very good example of how by combining the LED performance with the utility rebates that you can have a payback period in less than 1 year even versus some of the more efficient halogen. So with that, we'll sum up the legislation. We have the A-shape, which is going into effect. It began back in January of 2012, and will be the last piece of that will phase in January of 2014. That goes over A-shapes, decoratives, candles, and those types of lamps. The incandescent reflector lamps, which went into effect on July 14th of this year. It includes all the R and PAR and BR type lamps. And then finally, the general service fluorescent, which went into effect as well on the 14th of July. And it includes, primarily, it's going after T12 and T8 lamps right now. And that's where the focus has been. The government's been trying to kill off T12 for quite a while. The final slide that I have for you is just additional resources that are out there. So you'll notice from major manufacturers have websites to help you with that. Philips has one dedicated to the legislation, another one talking about the phosphor issue, as well as one dedicated to utility rebates. The GE legislation, Sylvania legislation information is given there as well. Government resources, so the Energy Independence and Security Act, or EISA, all that information is there if you want to bore yourself to tears with the details, as well as the DOE rulemaking, so that's the part that went after the incandescent reflectors as well as the TL legislation. And then finally, NEMA, that has some comments on both the fluorescent as well as the reflector legislation, and I think they do a very good job of summarizing it. So there's some resources for you if you're interested in getting additional information about them. With that, I want to thank everybody, thank the Green Restaurant Association for having us present. My contact information is there. Probably preferred is email. That's the easiest for me to respond to. And I'd certainly be happy to answer any questions at this point. So I think, Charlotte, you might have received a few?
Hi, Brian. Thanks again for that. That was a wonderful presentation.
Thank you.
So we've had a few questions come in. One question for you is, why is the federal government making 130-volt lamps not viable to make?
The thinking is that when an incandescent lamp operates at a lower voltage than its design voltage, it is actually less efficient. So it has less lumens per watt. So the same lamp, if you operate it at 130 volts, we'll say that it has 10 lumens per watt. When operating at 120 volt, its efficacy would drop to maybe 9.5. So in practical sense, you actually lose the efficiency, and that's why the government went after it. In actual applications, you are losing some of that efficacy, but you're saving wattage as well. So a 60-watt lamp running at 130 volt versus a 60-watt for that same lamp running at 120 volt would run at 53 watts. So you're saving some, you are saving some energy, and it was quite a big discussion with the government when we were going through that. But I think some of the environmental groups won out on that discussion.
Oh, wonderful. That's very helpful. So we have another question for you.
Okay.
Can you please comment on the problems with the MR16 and dimming? Dimming seems to be definitely something that people want, so it would be helpful to understand how that works with these kinds of models.
Yeah. So unlike the halogen, which is essentially is just a resistor, and all you have to do is just either give it more power or less power, and it reacts properly. The LEDs run off of a lower voltage than is supplied by the 12-volt circuit at an MR16. Therefore, in order to control the dimming and to control the power to the MR16, you have to have a buffer circuit of some kind in order to regulate the current going to the LEDs. The load on those circuits, so a dimmer switch, a dimmer is looking for a certain load to it, and if it does not have that load, then you can see some flickering with the lights. And what that is, that flickering is, it's the circuit trying to catch up with itself, trying to deal with the voltage input converted to a current. So it's Yeah, I think that's the basic way. We have a voltage source and a current-driven lamp, and during that conversion is where you end up with the problems. And that's why when you look at many of the manufacturer websites, they will, along with the whether or not it is dimmable, they will list dimmers with which it is compatible. And so there's a little bit of the reason behind it, as well as some of the solutions that you can, or ways to look for lamps that are compatible with your existing system.
Very good. On a related note to that dimming, another question has come in. Is there anything being done to LEDs to increase the temperature of the light as it is dimmed?
Some manufacturers, including Philips, I'll have to praise ourselves for a little bit here. We have something coming out called dim tone, and what that does is that it tries to mimic the dimming of an incandescent lamp. And so at full brightness, our dim tone lamps start at 2700K, and when you dim them down, I think we go down to 5 or 10%, they go down to 2200K. So that's the one of which I'm aware. Other manufacturers I have heard have come out with a similar lamp, but I have not seen them yet. So that's a special feature that is designed into the lamp and is not inherent in the design like it would be in a halogen or incandescent. And it's something that go out and check out the information that we have on our website. I think it's pretty cool. I come from the halogen world, so everything just kind of worked, and to see how the LEDs have been able to mimic it, it's pretty impressive.
It's really exciting to hear about the innovations in this technology. Just a reminder to all of you if you want to get your last questions in, look to the meeting chat in the left-hand corner of the webinar interface. Brian, another question for you. Do you have any sense on T12 inventory in the distribution networks across the nation? And if so, how many years supply do you see?
As far as T12 and years of, at this point I would not classify it as years of supply. I think you probably have a couple months of T12, and that you have to start really looking towards either a retrofit kit or the higher lumen per watt. But I mean, manufacturers just aren't going that way with T12. The government's been trying to kill off T12 for probably 10 to 15 years now in favor of the T8s and the T5s. So I highly doubt that there are years supply of lamps, and I would put it more in the 6 to 12 months range of lamps. I mean, you might be able to find spots here and there where you can find a particular lamp, but in general, I would expect those supplies to dry up probably in the next 6 to 12 months.
All right, that's very informative. Thank you. On that note, it looks like we're going to be wrapping up. A few more final items. First of all, just want to start looking into the prize of the 12 LED bulbs, those award-winning that did win that L prize. And the winner from today's participants is Mike Pichetto. And we have his contact information. We will be contacting him shortly after this webinar. He is from 3rd and Ferry Oyster House. And we're very, very excited for him. So congratulations to Mike for winning 12 of the best LED bulbs on the market. On that note, we will also be emailing all of you a link to the live recording of this webinar after this presentation once it is up. So please keep an eye out for that in the next couple of days. I would like to hand this over to Michael Oshman for a closing statement. Thank you so much for coming, and we look forward to continuing the conversation.
Thank you, Charlotte. Thank you, Brian. Thank you, everybody, for attending. Congratulations, Mike, on winning those bulbs. And we look forward to doing more of these types of presentations, open to your feedback. Anybody that's got further questions for Philips, feel free to email those over to Charlotte, and we will forward them on to them. If you have questions for the Green Restaurant Association regarding your restaurant or your products, or as a consumer, also feel free to email those, and we'll be happy to answer them. So thank you very much. Enjoy the rest of the day, and we hope you have a lot of success in creating energy efficiency in your restaurants. Take care. Bye-bye.